Hello everyone, welcome to Easy Chemistry by Praveen. So today we are going to discuss about the topic is POAC, Principles of Atom Conservations. So already we are discussing the each and every topic in a topic chapter wise we are discussing. Right now we are in the first chapter, some basics principles of chemistry we are discussing. So in this POAC is a important topic. So what is meant by POAC? POAC is nothing but like a law of conservation of the mass. In a given chemical reactions, the mass is conserved. So POAC is talking about the atom conservation. In a given chemical reactions, atoms are conserved. Atoms are conserved. Both sides, whether reactant side and the product sides is conserved. So atoms are conserved in the sense moles also shall be conserved in a chemical reactions. Moles also shall be conserved in a chemical reaction. Here no need to do the balance the chemical reaction. We are using the unbalanced chemical equations. So by taking off the one example, we will do how we will apply the POAC. We will apply. So how we will apply the POAC on this equation? So KClO3 gives rise to KCl plus O2. How we will apply? So we will apply the POAC on each atom. So we will apply the POAC on potassium, chlorine and oxygen. So reactant side and product side also we will apply. So now you can see that, for example, how many moles I am taking it as a KClO3 is a N moles. KClO3 is a N moles. This KCl also I am taking it as a N KCl, N number of moles of KCl. Here oxygen also I am taking as a N number of moles of the oxygen I am taking. How we will apply? Now only I said that we will apply the POAC on each and every atom on reactant and product side. So already we have learned atoms are conserved means number of moles also conserve both the reactant side and product side. So now you can see that apply POAC on potassium, both the side, reactant side and product side we will apply. So now you can see number of moles of potassium in KClO3 is equal to number of moles of potassium in KCl. So atoms are conserved in the sense number of moles also conserved. So now you can see how many number of moles of potassium in KClO3. We are taking it as a N number of moles of KClO3 in the reactant side. In a product side, N number of moles of potassium present in a KCl it is presented. So we know that atoms are conserved, number of moles also conserved. What we have to do the next step is, for example, here any number of moles is there, whether it is the 2 moles you can take 2 moles, whether it is 3 moles you can take the 3 moles. So general equation I have taken it as a N number of moles I have taken. Here you can see that in a KClO3 how many potassiums are present? 1 potassium is present, so you have to multiply the N number of moles of KClO3 with the 1. Here how many potassium atoms are present? Atoms all present because POAC, principle of atom conservation, 1 atom, so multiply with the 1. Okay, this we applied on the potassium. Like this we have to apply on the chlorine, like this we have to apply on the oxygen we have to apply. After that we will discuss some numerical. It is very useful for the doing of the numericals very easy. So now we can see apply POAC on chlorine. So same thing, number of moles of chlorine in KClO3 is equal number of moles of chlorine in KCl. So now we will do N number of moles. How many moles? N number of moles of KClO3. is equal to number of moles of Cl and KCl. How many moles? N KCl. Here how many chlorines are there? In n number of moles in KClO3, one chlorine is there. N number of moles, how many chlorines is there? Just you have to multiply how many atoms are there. One atom. Here in KCl, one Cl is there. In n number of moles, how many KCls? Just you have to multiply the atom, whatever the atom is there. You have to multiply. Same thing you have to apply on the oxygen also. You have to apply. See that apply POAC on oxygen in KClO3. So number of moles of oxygen in KClO3 is equal to number of moles of oxygen in O2. So how many number of moles? N number of moles. So N KClO3 is equal to how many number of moles of oxygen? N number of moles of the oxygen. In 1 KClO3, 3 oxygens are there. 3 oxygen atoms are there. In KClO3, 3 oxygen atoms are there. In n number of moles of the KClO3, how many oxygen atoms there? Just you have to multiply with the 3 atoms. So here also, in O2, 2 oxygen atoms are there. In NO2, how many? N number of moles of the O2, how many oxygen atoms are there? Just you have to multiply with the 2, you have to multiply. Finally, we will get 3N KClO3 into 2NO2 we will get. So if you apply POAC also you will get this one, or otherwise if you go with the mole ratio also, you can. For example, if you are going with the mole ratio, in the mole ratio what we have to do here, POAC unbalanced equation, no need, we can do. But in the mole ratio we have to balance the equation, we have to balance. So for example, if you want to apply the mole ratio, so 2 KClO3, 3O2, 2 KCl. For this you have to, whenever you are applying the mole ratio, you have to use the balanced equation. POAC, it is not required. Unbalanced equation you can go. So mole ratio you can take. For example, you are taking the mole ratio you are taking. So N number of N KClO3 upon the 2 is equal. So now what I want, so for example we want same thing relation we want, N KClO3 relation we want. So for example you can see that you can equate the with the help of this N KClO3 NO2, you can equate both. Otherwise N KClO3 and N KCl also you can equate. For example you can see N KClO3 is equal to, so if you want to equate 2 get cancel, N KCl will come. This is what only we have got. But if you want to with respect of the oxygen, so you can get that N KClO3 upon the 2 is equal to NO2 by 3. So automatically you will get 3N KClO3 in place of oxygen. So 2NO2. With the balanced by using of the mole ratio, you can get this one. POAC also you can get this also. Now we will discuss the one numerical in the IIT JEE mains. So see the one numerical. 27.6 grams of K2CO3 on treated with the different series of reagents. So different reagents. So finally what he got, all the carbon atoms are replaced. Of all carbon atoms are replaced. So it converted into K2Zn3. So iron CN6 12. So this is 27.6 grams of K2CO3. What is the mass or weight of the product? They are asking. So by using of the, without balancing this equation, by using of the POAC, how will you? So now they are asking about the, all the carbon atoms are replacing. So no need to apply the POAC on potassium or the oxygen. Just to apply the POAC on the carbon. Why? Because here in the question clearly they mention all of its carbon they mention. So by using of the, if you are applying the POAC on carbon, we can easily get it. So now you can see, apply POAC carbon. So now you can see number of moles of carbon in K2CO3 is equal to number of moles of carbon in K2Zn3 iron CN6 taken twice. I am taking NK2CO3. I am taking in NK2CO3. In 1K2CO3, 3 atoms are there. In NK2CO3, n atom. How many atoms? So just you have to multiply how many atoms are there. 3 atoms. Here also same thing. NK2Zn3 iron in number of mole in this moles, how many carbons? 6 into 2, 12. N number of moles, just you have to multiply with the 12. You have to multiply. Okay. So now how will you get the weight of the product? So we know that number of moles is equal weight by the molecular weight. Already in the question they have given the molecular weight they have given. So same thing, weight how much? 27.6 gram. Molecular weight for this K2CO3 how much? 130. By using of the number of moles, that means mass of K2CO3 upon the molecular weight of K2CO3 is equal mass of K2Zn3 iron CN6 taken twice upon the molecular weight of K2Zn3 iron CN6 taken twice. K2CO3 upon the molecular weight of K2CO3. Mass of K2CO3 already they have given. How much they have given? 27.6 grams they have given. In the question if you see that 27 grams of the molecular weight they have given. So here mass of how much? On we are applying the POAC, just to remember that we have to multiply the whole equation with the 12. Why? Because 12 carbons are there. Just you have to remember this. So what is the molecular weight? 138 is the molecular weight. So mass of 12 into K2Zn3 iron CN6 taken twice into 12. So molecular weight how much? 698 how much? So 138 27.6 upon the 138. So by doing the 0.2 we will get. So mass of the K2CO3. How will you do? If you do the cross multiplication 698 into 0.2 upon the 12. So by doing, if you get that 11.6 grams of the product. So this is 227.6. This is 11.6 grams of the product is formed. So the next question, 0.32 moles of lithium aluminum hydride LiAlH4 is either solutions or was placed in a flask with the tertiary butyl alcohol. So how much? This is 0.32 moles they have taken with the, they are placed with the tertiary butyl alcohol. So this time what will happen is converted into the product, it is converted LiAlH2. So they are asking the what is the mass of the product they are asking. So before that one numerical they have given the mass, they have find out the product mass, but here they are asking about the reactant moles they have given, but here they are asking about the product mass they are asking. So apply the POC on the lithium on the both sides. So number of moles of the lithium. So for example you can see n number of moles lithium aluminum hydride. So how many lithium? One lithium. Just you have to multiply with the 1. Here you can see that only 1 also is there. So 3. So here they have given the moles, they have given nothing but number of moles. How many moles? 0.32 moles they have given. They are asking about the mass they are asking. We know that mass by molecular weight. By using this we can easily calculate the mass of the product. If you equate these two, and that means reactant side of the lithium and product side of the lithium, if you equate, automatically we will get the answer. So here what is the molecule? 254. So molecular weight is equal 254. So now you can see 0.32 is equal mass, let us say it is x, molecular weight is 254. Here how many number of moles, how many atoms are there? One atom. So 1 into n LiAlHC12H2O3 upon the molecular weight. So molecular weight how much? Molecular weight is 254. So we want the mass, 1 grams of the mass. By applying of the POAC without doing of the balancing of chemical equation, like this you can solve the this type of the numerical.